Hello everyone, welcome to Reactify Labs. Today we will talk about Neo4j. Hmm, Not H, it's 4. Yes. So what is Neo4j? Neo4j is a graph database. Why graph database? There are some things which cannot be represented in tabular format like this, right? There are some things which can be represented well if they are represented using a graph. So the best example that can be given would be, let's say Facebook or LinkedIn. Okay, so just take this example. Um, this is Facebook, this is you. Okay, so you have three friends. Hmm? So you are connected to your friends, friend 1, friend 2 and friend 3, right? So later what happens is, let's say mm, you got a new friend request, okay, maybe for 4, but before that let's say 3 has some friends, okay, let's say 3 has 2 friends, A and B. So now what happens is you start getting suggestions that, see, you may know A because you have one mutual friend. You and A have one mutual friend, which is 3. So you might know A. Just send him a friend request. That's what Facebook suggests you. In LinkedIn, this is called second degree connection. Means you know somebody who knows A. So this is second degree connection, right? So this is how graph database is used. Let's say tomorrow what happens is you there was some person called Z. You never got this person in suggestion, but there is some person 4 who is friends with Z. Tomorrow what happens is you became friends with 4, or 4 became your LinkedIn connection, or you became friends with him on Facebook. Both are same, right? So as soon as you connect with 4, you start getting recommendations for Z, that you might know Z because 4 knows Z, right? So Z is your second degree connection. Similarly in Facebook it will be like you and Z have one mutual friend in common, right? Similarly, let's say A, if A is friends with this 1 also, then you will see the recommendation for A also showing that you and A have two mutual friends in common, 1 and 3. So you should consider adding A also as your friend, right? So this is all possible because of Neo4j. So that's the role of Neo4j in our uh, systems which leverage graph extensively. So now that we have some understanding of Neo4j, let's start discussing about it. So we will first start with the introduction of Neo4j. Then we will talk about the concepts which are important to understand Neo4j. Then we will talk about the architecture of Neo4j. After that, we will move to operations of Neo4j. After that, we will see some of the advantages of Neo4j, then challenges, and we will end with some real world use cases of Neo4j. Okay. So we already saw one use case which was suggesting mutual friends, but there are some more as well. Um, anywhere where you can see a connection can be an application of Neo4j. Another very quick example that if I have to give, I'll say you are on Amazon, right? So you see some, let's say, couch. So as soon as you see the couch, if you scroll down, you see recommendations for more couch. Why? Because those couches are similar to this particular one. So depending on how similar they are, you will see them in the order, right? So let's say you selected one more. So how similar the other ones are to this one, you start seeing these recommendations. So all this is possible because of the graph database. I'm not saying it's only because of Neo4j. There are other graph databases as well. Neo4j is one of them. So I'm discussing one, Neo4j. You can think that other graph databases will be having similar implementation, but Neo4j is the most popular one. So I'm discussing this one. Okay. So let's talk about the introduction. So Neo4j is an open source NoSQL database. Okay. It's an open source NoSQL database. As you can see, everything which doesn't have a structure is a NoSQL database. But SQL has the structure of the table, right? Fixed structure. But everything which does not have the structure, as I've discussed in my other video as well, which was purely dedicated to SQL versus NoSQL. So it was like wide column, graph database, time series database. What else? I forgot. So, but yeah, there were I think 5 or 6 kinds of NoSQL databases, right? So Neo4j is one of them. Okay. So it's an open source NoSQL database that stores data in graph structures, right? That stores data in graph structures rather than traditional tabular formats. Traditional tabular formats, right? Unlike relational databases, which use tables to define relationships, Neo4j uses nodes, relationships, and properties, and thus provides a natural and efficient way to model connected data. So Neo4j is a highly scalable native graph database designed to leverage data relationships at first-class entities. It is optimized for complex queries and large data sets, which makes it a powerful tool for use cases involving highly connected data such as social networks, as I said about Facebook and LinkedIn, recommendation engines, as I said about Amazon, and fraud detection systems, which we will talk about later. Okay. Now let's see what are some of the core concepts involved in Neo4j. So first thing is nodes. So nodes are the fundamental entities in Neo4j. Nodes represent objects or entities in the graph. Each node can have multiple properties which are key value pairs. So nodes can be labeled to categorize them into groups. Let's say in the Facebook example, we used node as you, right? So there the node was person. Maybe if we have to model a graph of the city, the node will be the city name, right? If we have to model that recommendation system, as I talked about in Amazon, so there the node was a product. So the node can take any value, right? Nodes can store attributes like these: person's name, product's price, a lot of things. Okay. So next thing is relationships. Relationships are directed connections between nodes that describe how the entities are related. They are first-class citizens in Neo4j, meaning they carry significant importance and can also have properties. So, the best example that I can give you is again Facebook example. So this was the node, this was the node. You were person 1, another one was person 2. What is the relationship between you two? You were friends, right? And since it's directed, so let's say friends is mutual actually, both it's friends is like this, but let's say you are on Instagram. So there if you follow somebody, it's a one-way thing, right? So other person also needs to follow you. So the arrow goes like this, right? So unless both of these people will follow it, both will not be mutually connected to each other, right? So you both need to follow, so there will be directions. Similar thing goes for LinkedIn. Connection is established like this without direction, but if you have to follow someone, it will be in a directed manner, right? So yeah, relationships have a direction which indicates the nature of the connection, such as friends with or purchased. Relationships can store data about the connection, like the date two people become friends or quantity of the purchased item. So for example, in the social network example that we gave above, a friends with relationship might connect two person nodes representing a friendship between two people, right? Next is properties. So properties are key value pairs associated with both nodes and relationships, storing additional information. Properties add context to nodes and relationships, making queries more powerful and precise. Properties can store different types of data like strings, numbers, or dates. For example, a person node, right? So this is the node, which was the person. So this person node can have properties like the name. The node will have properties, name, date of birth, maybe email, maybe address, a lot of things, right? So these are the properties of this particular node. Now let's say there is another node, another person 2. Again, this person will have these things like name, date of birth, email, address, a lot of things, right? So these properties, these are the properties of this node, and there is a relationship between these two, right? So again, this relationship also will have properties like, let's say person 1 is following this person since, let's say, xyz date, right? So this is property, right? So this is node, this is the relationship, and this is the property, right? So yeah, next is the CQL. CQL is Cypher Query Language. Cypher Query Language. So Cypher is Neo4j's declarative query language, which is designed specifically for querying and updating graph data. Cypher uses ASCII art-like syntax to describe patterns in the graph, which makes it intuitive to find and relate data. Cypher supports complex queries involving multiple relationships, aggregations, and conditional logic, right? So for example, let's say if we have to find on the Facebook, let's say your name is person P1, right? So if I have to find all your friends on Facebook, so the Cypher query will go like this. It will be match a person which has name P1, right? And that person is friends with, actually I am short on space. So this person is friends with what? Let's say a friend and return this friend dot name. So what this query will do is, this is you, okay? The query starts from here. So this will match, this will find all the friends of person P1, right? All the friends, all the people person P1 is friends with, and it will return the name of all the persons, okay? All the friends of that person P1 or you. So this is how CQL works. So this is just a simple example of a CQL, right? So now that we have covered the concepts, let's move to talk about architecture. Architecture of Neo4j. First is native graph storage. Neo4j stores data natively in a graph structure, meaning nodes, relationships, and properties are directly represented in the storage engine without requiring the translation that occurs in relational databases. This native storage allows for efficient graph traversal and queries, as the database engine directly understands graph structures. Neo4j supports ACID transactions, atomicity, consistency, isolation, and durability, and thus it ensures data reliability and consistency. Okay. For example, when querying for a path between two nodes, Neo4j can directly traverse the graph without the overhead of joins required in relational databases, right? So let's say if we have to find like something, let's say this is your table, okay? So in relational database, this is how it's stored. For example, you have 5 friends. So your name is, let's say, A. You are friends with people named B, C, D, E, F. So you have one table. So A, B, A, C, A, D, A, E, A, F. Okay. This table will contain the details of all your friends, right? And let's say there is another person, let's say B. So B is friends with A, obviously. B is friends with C, B is friends with G, B is friends with H, and B is friends with K. Now, if you have to find the mutual friends, how many mutual friends are there between A and B, you will have to join these two tables, right? And only then you will be able to find out. But Neo4j does not do that. Neo4j will just represent it as graph. So it will be like A, B, A is friends with C, D, E, F, and B is friends with A, obviously. B is friends with C, and B has other friends G, H, and K, right? So now if you have to find the mutual friend between A and B, it's just this C, right? So this is how it's directly stored. It's stored as a native graph, so it's easier to find out rather than going through the tables and joining them. Here I have taken a simple example, but otherwise, let's say if you have thousands of friends, then it becomes very difficult to find out, right? So yeah. uh, Another good example, you can say that who has thousands of friends? People don't have thousands of friends, but yes, people do have thousands of LinkedIn connections. So in that case, this is very helpful, right? Next is high availability and scalability. High availability and scalability. Neo4j is designed to be highly available and scalable, with features that support large datasets and distributed environments. Neo4j supports clustering, which allows multiple instances of the database to work together, thus providing fault tolerance and load distribution. And for very large datasets, Neo4j can distribute data across multiple machines, thus enabling horizontal scaling. So for example, a global enterprise might deploy a Neo4j cluster across multiple data centers to ensure that their graph database is always available even in the event of a regional outage. So I'm not going to discuss more about it. Anywhere, like anywhere where there is high availability, there is redundancy, right? And if there is high scalability, it means horizontal scaling will be there. It's horizontal scaling, it means the data is distributed, sharded, partitioned, so a lot of things happen. So yeah, you know what. And next, let's talk about operations. What operations happen? Just like any other database, first will be insertion. Nodes and relationships are created using Cypher or via APIs, with properties being added simultaneously. For large datasets, Neo4j supports batch insertion methods that allow for efficient data loading. For example, a company might batch insert a dataset of customers and their interactions with products, thus forming a graph that can be later queried for recommendations. Next is, after insertion, you will query. Querying. Data is retrieved through Cypher queries, which can explore nodes, relationships, and properties, allowing for complex pattern matching. Neo4j's architecture allows for deep graph traversals, finding not just direct relationships but paths that can span many nodes and edges. For example, a fraud detection system might use a Cypher query to find circular patterns in transaction data that indicates potential fraud. And data updates. Nodes and relationships can be updated in place, with properties being modified or added as needed. Neo4j supports optimistic locking to manage concurrent updates, reducing the chance of data conflicts. For example, in a social network, when a user changes their profile information, the corresponding person node properties are updated, right? So again, this is Facebook, this is you. So let's say tomorrow you add a new job or a new mm, relationship status or a new education. I think the same applies to LinkedIn as well. So the node remains the same, right? The update happens in place. So this is what this update is talking about. The updates happen in place. So this will log the particular node and update it, and that's it. Hmm. Next, let's see what are the advantages of Neo4j. First is efficient relationship management. Neo4j's native graph storage is optimized for managing and querying relationships, which makes it ideal for use cases where connections between data points are crucial. Next is flexible schema. Neo4j's schema optional model allows for agile development, where the structure of the data can evolve without requiring schema migrations. Next is intuitive querying. Cypher's pattern matching syntax is intuitive and powerful, allowing developers to write complex queries with ease. You already saw that before, how easy it was to find out all the friends of a particular person, right? Next is scalability. Neo4j's clustering and sharding capabilities allows it to scale horizontally, thus handling large graphs efficiently. This we already talked about. And next is strong community and ecosystem, because it is open source. Neo4j has a robust community and extensive documentation with a wide range of integrations and tools available. Okay. Now let's see the challenges associated with it. First is learning curve. While Cypher is powerful, it can be challenging for new users to learn, especially those with a background in SQL. Because if you are very good with SQL, you will have a hard time understanding a new language, right? So I remember the similar kind of problem. This happened when I was learning Python. So I knew C++. The significant difference between Python and C++, apart from many other things, is semicolon. So in Python also, I used to put semicolons, and it would give me something syntax error or something like that. I forgot what it was, but yeah, this is one basic example. But still, I have other problems also in Python. Even while writing Python, I used to write C queries, C++ code. Like in C++, you write bracket after for, but I think in Python you don't. So a lot of things you need to adjust a lot if you are learning some new language for the first time, or if you are learning your first language. It's easier for you to learn as compared to when you are transitioning from a different language, and more painful when you are already almost an expert in the other language and then you are shifting to a new language. It becomes really painful. Next is cost. Neo4j's enterprise features such as clustering and advanced monitoring tools come with licensing costs that might be prohibitive for smaller organizations. Next is write performance. In some cases, Neo4j can have slower write performance compared to other databases, especially when handling very large graphs with complex relationships. And next is limited use cases. While Neo4j excels in scenarios involving connected data, it might not be the best choice for applications that require complex transactional logic or need to handle large volumes of unconnected data. Okay. And let's end it with some real world use cases and examples. Use cases and examples. So first one is, we talked about this a lot, social network analysis. Neo4j's ability to efficiently manage relationships makes it ideal for social network analysis, where understanding the connections between individuals is key. For example, a social media platform uses Neo4j to model users and their interactions, enabling features like friend recommendations, influencer detection, and community discovery. Next is fraud detection. Financial institutions use Neo4j to detect fraud by analyzing patterns in transaction data, identifying suspicious activities that may involve multiple seemingly unrelated entities. For example, a bank models customer transactions in Neo4j and uses graph queries to detect circular payment patterns which are indicative of money laundering. Money laundering, if you know, so like the money keeps on going, like this will keep traveling in the circular pattern. This is what happens. I am not an expert in money laundering, so I cannot tell you more details about it. But yeah, from what I have studied, it goes like this. So, like, if it's an income, you have to pay taxes, right? But if you receive it as a gift, then you don't. And gifts also have some limit. Let's say below X amount, you don't have to pay any taxes. So if you continuously receive same X amount in same circular pattern, then it's an indicative of money laundering, right? So this is what it is. Next, we have talked about this recommendation engines. Neo4j is used to build recommendation engines that leverage the relationships between users, products, and preferences to generate personalized suggestions. For example, an e-commerce site uses Neo4j to recommend products to users based on their purchase history and the buying pattern of similar users. This is called content based recommendation and collaborative recommendation, right? So content based is basically, if you like a product P, so other products similar to P will be recommended to you. And collaborative is, let's say this is you, this is people around you. Okay, so what people around you are using, you will get all those recommendations. So this is collaborative. Similar recommendation works in your Instagram, YouTube, everywhere. Let's say you are new to Instagram, right, or TikTok. So what will they suggest you? What will Instagram suggest you? Instagram does not already know what you like or dislike. So what it does is it takes your location, okay, and it finds out all the people near you and it sees what they are liking and it assumes that you might like that, so it will suggest you that thing. So that is collaborative recommendation. Okay. And content based recommendation happens once you start watching Instagram. Let's say you scrolled it for 2-3 days, so Instagram understands your pattern that okay, you like these things, so it will start suggesting you those things. Next is supply chain management. Supply chain management. Neo4j can model complex supply chains, providing visibility into the relationships between suppliers, manufacturers, and distributors, optimizing logistics and reducing bottlenecks. For example, a global manufacturer uses Neo4j to map its supply chain, identifying the impact of a disrupted supplier on its production lines and finding alternative routes. Like again, if you see Google Maps or any map, it's just a connected graph, right? So this is connected to again this. So this is how the modeling happens, and this works really well in supply chain as well. And using these graphs, it's easier for the supply chain people to model the most efficient route for their delivery or for logistics or for their inventory, a lot of things. So Neo4j plays a very important role there as well. So yeah, that's all there was in Neo4j. Now if somebody asks you to design a system for, let's say, Instagram or Facebook or LinkedIn, you can talk about Neo4j databases. Okay, so yeah, that's all there was in this video. Thank you for watching. Please remember to like, share, and subscribe. I will see you in the next one.